All right, got a distributor here. This distributor is from a job that I kind of finished today. I got the engine going by replacing the distributor. A couple things didn't set too easy as far as the repair, and some anomalies I saw looking at the waveforms and some data I collected over a couple of visits. A tech had gone there previously and the engine had overheated. My first visit, the engine was binding. I had a starter issue, I had to replace the starter, so I really couldn't get any data. Came back and I did a cam crank correlation, brought the waveform home, and the cam and crank waveforms didn't align. We use a scope. You can check timing just like you would line up a cam and a crank gear with a timing chain. If you have a cam and a crank sensor, you can check timing without pulling all that apart. So anyways, here's the distributor, regular GM flat top style distributor. What I mean by flat top is it's got a flat top. One of the cool things about the flat top distributor, I'm trying to balance my phone here, my GoPro is dead, so you may see that. There's a flat, so it's mostly round, but then there's one side is flat. And what is cool on that is plug one, the post for that lines up with this corner. Now that corner is also mirrored on the distributor itself because it aligns, so you have all round and then this one flat. So when you're stabbing the distributor, you can line that up to that corner. Now you know your distributor is pointing at plug one. This distributor, you cannot adjust timing. The fork that holds it down, some distributors you can go back and forth to adjust your timing. This is an emissions engine, so the timing's locked. This is a square post here, and the fork keys into that, so there's no adjustment. So you have to get your gearing right for that cam mesh to mesh into the cam. Once it meshes into the cam, you also got to get into the oil pump. That square drives the oil pump. So you got a lot going on, and if crank the engine without the distributor, you got to find top dead center of one, which I did. I just put my thumb over, removed the plug, got compression, then I stuck my bore scope in there and got it close. One of the cool things also about a GM, if you do not have this style distributor, when you set it in, this rotor points towards cylinder one in the engine. So anyways, my problem was, well, I'll show you. If you look in the background over here, you can see as I rotate this, you can see I get a square wave. I get about a 5-volt square wave. So let's do one revolution. So here's the post here. We'll rotate one revolution, and you can see I get one square wave. So every revolution of the cam, I get one square wave like that. The crankshaft also has that style sensor, but that has 4 notches per revolution, where this only has 1. So one revolution of the crank will create, we'll make it look like the crank on that photo. That would be one, that's what one revolution would like, 4 square waves. And then the cam, this cam sensor here, would only give you 1 square wave, so you get 4 to 1. Now, the crank, for the auto ignition cycle, the crank spins 720 degrees per every 360 of the cam. So the crank spins twice for every 1 revolution. And if you think of it on a 4-stroke engine, each stroke being 180 degrees of rotation, you get your compression 180, your power stroke another 180. That's already 360. We got our exhaust stroke, there's another 180. And then our intake stroke, there's another 180. So 720. The cam kind of controls that whole segment, that whole process for one turn. So my problem was, I didn't get a good cam crank correlation. When you hook up your scope, you would expect to see 8 square waves from the crank overlaid exactly in half, divided by 1 square wave of this. So during the low portion or the high portion of the square wave, I should have 4 from one revolution of the crank. And then during the low section, I should have another 4. So I should have it 4 and then another 4, making 8 in one total revolution. The problem was my signal sometimes would have 3 and 5, 2 and 6, which makes no sense because the cam and the crank should be locked. You should the signal should correspond, and I'll show you that in a second. So this is kind of binding. This is not spinning free. So I was trying to think of how that could happen, because when I put the distributor in today, the engine worked fine. There still could be some other noise. I suspect the lifter might not be pumping up or draining down when the engine sits, because the first few revolutions or the first few crank cycles, I get a well, I'll show you that in the next video here. I get some kind of what sounds like binding. So anyways, I found out here why I'm getting intermittent signals. So if you look at this distributor, and I'm at my high spot, the only way that high spot could go away is me rotating it so the sensor is not calling for that. So let me put on the high spot, and now if I push up on that distributor, you can see my signal can come and go. And that is no good. So there's a lot of play in this. So I pick up on that rotor, I lose my signal. I push it down, I get it back. I push up on it from the bottom here, and I lose my signal. So, and I noticed there was some rubbing on the top of the cam there. So that could create false square wave. So without rotating the engine, if you look at, I can create a square wave without rotating the engine. So there's the problem. So it pays to bring parts home and look. So I think this gear was popping up, popping out of the shafts due to the restriction. Like this gets hard to spin. Should spin really free. Okay, so that's the problem there. So now I'll show you the waveform that kind of I wasn't happy with. So we'll get the computer here now. So let me pick this up. So let me zoom out to full. So here, let me shut off these. This is my ignition firing right here. These are ignition strikes right there. Okay, not really happy with those ignition strikes. So I get some ignition, and then it stops. And you can see, then the engine tries to crank again. It pauses, tries to crank again. So when I overlay the crank, I get some crank square waves, and now these are going to change in length because as the engine's cranking, the faster the engine cranks, the shorter these are going to look in time. And then when the engine slows down, they're going to elongate there. So you can see I crank, and now this is the cam gear. Well, let me see. Nope, this is the cam gear. So these are 4 revolutions, but I'm getting a bunch of strikes right here. I'm not happy with. And then we pause in time, and then we try again. We fire off, and then the AECM shuts off ignition. We pause. So let's look at this a little further, and we'll zoom in. Window. So let's look into here. So what am I going to do? I'm going to zoom out. We're going to shut off the ignition strikes. We don't need that. And we're going to zoom window in here again. So if you look here, I have 1, 2, 3, 4, 5 These are the crank gears. Remember, one revolution of the crank is four square waves. 1, 2, 3, 4. I got 5. And then I have 3. 1, 2, 3 on the high side of the cam. So starting here on the yellow, going down, over, up, and down. And actually, I'll get some cursors to show us one revolution. And actually, I'll put one revolution in on the screen. Just one total revolution. So this is one total revolution. All the signals that would be in one revolution. So if you look at it now, let me just adjust this a little better. So this is one revolution. Let me shut off the green. So here's my square wave. This is 1, over, up, down, and 1. So this is one revolution of the cam. So I should have 2 revolutions of 4. So I should have 8 crank pulses. So let me turn on the crank signal. I have 1, 2, 3, 4, 5, 6, 7, 8. The problem is they're uneven. I got 1, 2, 3, 4, 5, then 1, 2, 3. It should be 4 on the low side and 4 on the high side. It should be even, where I'm not even. I got 1 more on this section and 1 less over here. Now, let's remember, 5 and 3. Now, if let's say we're fine with that. Let's say that was the actual timing, like the engine jump timing. Well, it should not move because you have a timing gear and a chain. It shouldn't move. So now let's look at this section. We have 1, 2, 3, 4, 5, and then 3. Okay, the same one. This is the next revolution. Okay, I wouldn't expect it to move. So here's the next one. 1, 2, 3, 4, 5, 6, and then 1, 2. So now the cam and the crank are tied together with a timing chain, and all of a sudden we have 6 and 2. We always have 8, but now the crank has moved over. Now the question is did it physically move over, or was it caused by that sensor anomaly that we just saw on the scope? My guess would be, looking at this like this, I would think I had like I'm skipping. It's possible that I'm skipping. I have a loose reluctor. I could have a loose reluctor wheel. So the gear that it actually reads. So you could have good physical timing, but the actual sprocket that it reads could drift back and forth, causing that. You could also have actual movement of the timing, like a timing chain skipping, or you could have a sensor anomaly where the sensors are misreporting, or the distributor is popping out, and the distributor has jumped the tooth or whatever. The fact that I've put in the new distributor and it works fine and I don't hear any mechanical noises, I'm hopeful that there's no other mechanical damage, but I can't guarantee it. We'd have to rip the engine apart to see if I have any loose reluctor wheels, and I haven't been able to run it too long because I have some leaks that I got to take care of. But anyways, you can see where we went from 1, 2, 3, 4, 5, 6, and 2. Let's go to another one here. And then we got a 1, 2, 3, 6, and 2. 1, 2, 3, 4. And then we're back to 5 and 3 again. So, let's see. I should be able to. Probably shouldn't be bringing up my. Well, no. Let's see. I think I'm going to bring up my Facebook because I posted something, but probably not the best thing to do. Ignition secondary relative with sync 2. So here's another one. We'll take that and we'll load this data. This is a relative compression test. What this is simple oscilloscope test. You put your one channel on battery voltage, and as the engine cranks, we start with battery voltage. Then each cylinder, as it comes up on top dead center, I got music, we're going to shut off. Each cylinder as it comes up on top dead center should it should create some resistance for the starter. That resistance should drop voltage, which we can see. Now, if every cylinder has the same amount of compression, you should drop voltage equally. It should drop the same amount of voltage, so therefore you should have a nice sawtooth pattern here. So if I load, so let's go to relative compression, RC with sync 2, RC with sync. Okay, let's look. All right, so I'm going to take a zoom window here, and I'm going to zoom into this pattern. You could see one, so let's get some cursors. What we can do is we can mark these two high ones, and then we can mark cylinders. Let's say we have an 8-cylinder. I'm not going to put, I don't care what the firing order is, I'm just going to put just a generic firing order. So we can see 1, 2, 3, 4, 5, 6, 7, 8, and then back to 1. You can see that it looks like one cylinder is causing more resistance, more voltage drop. These other ones are pretty even. Now, I saw this happen on my previous visit, and it was much worse. And then over several tests, this pattern evened out, which could mean like I could have maybe a lifter that's bleeding out, it's not pumping up fully, and then as I crank the engine, oil pressure builds up, and maybe it's not opening an exhaust valve or something, so we're creating too much compression in one cylinder, causing too much voltage drop. I don't know, because so after about 5 or 6 crank cycles after the engine is sitting, this pattern gets a little better. So now we don't know what cylinder it is, right? So what we would do to find out where we are in this pattern, we just see the repetition. If we know we have 8 cylinders, we know this is one cylinder. We don't know which one yet. And then we know that this is the same, this cylinder here, this mark here is from this cylinder here, because we can count the amount of cylinders away, but we don't know where it is. So what you do, we put an ignition sync in. But here's the problem. I was clamped around plug wire number 1. Okay, so plug wire number 1. Hold on one second. Plug wire number 1 should not, especially on a distributor, should not fire 4 cylinders. Let me take this. Should not fire 4 cylinders in a row, or 5 cylinders in a row. Almost like the distributor did not spin, and it just sat there skipping, making that false square wave, making the engine see a square wave from the crank. So how could this happen? Let me try to explain this. It's the engine's getting the ECM needs to see the crank position sensor, and it needs to see the cam sensor. And as long as those correspond to a pre-programmed algorithm, it's going to fire the coil, which wherever the distributor is pointing, it's going to shoot the spark out that spot of the distributor. If my distributor was not spinning and it was popping out of the mesh, staying pointed down one, plug wire, and popping up and down, creating the square wave, satisfying the ECM's algorithm, seeing that square wave, it's going to start to fire. And it's going to fire. We shouldn't see, if I'm on a 1 plug wire, we shouldn't see this plug wire fire until the 9th, we should see it fire here, not here. So 1, then 2, 3, 4, 5, 6, 7, 8. Then it should fire here again. It shouldn't fire every cylinder 1, 2, 3, 4, 5, 6. That makes me think that maybe that distributor was plopping in and out. I don't know. This is why mechanics lose sleep at night, because you see things during the at least the good technicians. You try to reconcile stuff you see during the day. Even though the engine's running, we're not happy until we know the reason for all the readings we got. Why we're seeing certain readings. Let me load one more. This video is kind of getting long here. Let's see. I'll load this data here. So this is. Oh, this is perfect, I think. So I can get a good crank signal when I removed ignition. So when the engine didn't fire off, my pattern stayed the same. 1, 2, 3, 4, 5, and 1, 2, 3. So it seemed when the engine, so I disabled ignition, so I didn't allow the engine to fire off. So it seems like, and we kept this 5 and 3 pattern here, so it seems like the force of the engine firing off is what shifted the distributor and made it skip, made that signal go to 6 and 2, and then back. But I think the distributor skipped, possibly. I think it skipped and became 1 off. And I actually took a picture of this. I took a picture of this square wave and I actually put it out. And you know what we're gonna do? And actually, I put a video out here. Just to confirm. I think I'm in here. I wanted to know if I had the right, if my file was correct. Here we go. So I put this question out, was this correct? And I was looking for a known good. View more. Oh, hold on. And people were nice, and they sent me back the correct waveforms. And you can see 1, 2, 3, 4, 1, 2, 3, 4. You can see 1, 2, 3, 4, 1, 2, 3, 4. Where I have 1, 2, 3, 4, 5, and then 1, 2, 3. And again, this guy 1, 2, 3, 4, then 1, 2, 3, 4. That's the whole ignition cycle. You can see I've got 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, and then when the engine fires off, it actually shifts it back. So hopefully, the new distributor, it's working, it's running. Hopefully that shaft play that we messed with in the original video I took is the culprit. Only time will tell. There are some other things I got to do when I go back. We got a couple other issues, but the engine's running, new distributor, and we think we resolved it. So kind of a all over the place video, but it's just how my brain works, and I thought I'd show a little insight and a little of the frustration of what technicians go through, and that will be it. Adios.